All right, because I can't set up anyone anymore. My part of the presentation is going to be dealing with how to start loving Neurodesk, cloud workstations, performance computing, and teaching. So basically giving a little bit of example how I've been using this type of setups for teaching, which is this is in a way, I suppose. So first, a small declaration of potential conflict of interest. So I am a contributor to the Neurodesk team, and I may be slightly partial in my excitement about this. So I also stole a couple of slides from Stefan, so I'm probably double. Yeah. Anyway, we have a publication out, which is Renton et al. In Nature Methods. It's basically like a background about reproducibility and that sort of stuff. All right. So why would you worry, or what are things you might want to be worried about? So there is so many science tools require Linux, but they're not really all that easily available. You can, of course, try to kind of compile them from source for your sufficient Linux branch that you have, but that can be extremely hard, extremely frustrating. And I, as a disclaimer, I've probably succeeded about like 3 compilations throughout my life. And I try not to do that whenever I possibly can. So this is kind of one of the things I hate the most. The other problem is the continuity problem. That is, operating systems evolve and change, and old software often doesn't work anymore. I had a major event of that sort when I was like a postdoc. I used to use the Mr. Vista tools that were based on MATLAB and large visual cortex imaging. There was it's like an app or like an application that rendered surfaces, and then you could look at them in the operating system and in the GUI, and that required like 25 in Russia, and someone compiled it for macOS, and that sort of worked. Beautiful, and if nobody had the source code anymore, or wouldn't be able to compile it into a newer version. And there was two applications. And then at some point, macOS said, well, we don't want 32-bit anymore at all. We were basically stuck having a couple of workstations in the lab running on macOS El Capitan, which is one of the next version that supported 32 bits at all. And you know, is from September 2015. So that's that problem became more and more problematic. And at some point, we kind of had like some 11-year-old iMacs in my lab, and hoping they don't break down, because the moment they would basically be able to do something. I was kind of hoping I'd find someone here that uses Mr. Vista tools or does anything like that. So can we make a module for Neurodesk that runs the Vista tools? That would be really, really awesome. Okay. All right. So the other problem that we basically, or that this is sort of addresses here, is the portability problem. And basically, if you work on many different platforms, for example, your notebook, a cloud, or your lab workstation, like a big, powerful computer in the lab, on a cloud provider, or in a university high performance cluster, you need to reinstall a host, not just one, but a number of software packages again and again and again, and again and again and again. So these are all problems. The other problem is the reproducibility problem that has been named. That is basically that any software package that relies on underlying libraries that is provided by the operating system or that's shared with someone else, sometimes that can result in different results. For example, the glibc, which is one of the basic libraries, used by many software tools. I'm running this on my wire. So version 2.5 and 2.18, they deliver slightly different floating point results. So when you basically run a big analysis pipeline, for example, in a situation that you have a multi-institute study and one has one group and the other location has the other group, and one have GLIP 2.5 on the server, or they have 2.18, you get slightly different results. These are very subtle, but they can become significant. A few thoughts that I could probably add to that is, so this has been hyped as a big problem. I don't necessarily think it's always, well, in most cases, it's not that massive of a problem. So my view on that one is that when different results from something like GZ 2.5 or rounding any other rounding errors, beginning to fully impact the results, I would suggest don't blame GLIP. But basically rather blame your understanding of your methods and your science. That's just like a bit of personal sort of advice here. Repeatability is a little bit more than that, because if you repeat an experiment with different subjects, it should be still reproducible, but you're probably going to get more variations than you do from GLIP C versions, right? So any outcome that you have should be robust. Against those problems too, otherwise it's probably not that great. So meaningful reproduction means result interpretation must survive sample changes. So there is a bit two aspects of reproducibility, I suppose. Because despite that sort of like philosophy that say like, well, if it's these differences are so small, and they kind of throw you apart, and you have to kind of think a little bit about what you're doing. That is probably true. Nevertheless, you still have the desire to accurately and detailed document the methods that you have been using in any given instance. And the detail of the communication that you require can actually be gone too deep. Apparently, down to the level of which you see it. And you don't write that in the paper, right? But you sort of should or could. What our sort of intention is here is what we also using here in this workshop. It's a relatively new solution that is what Neurodesk. And Neurodesk and Neurodesktop. Neurodesktop is a virtual machine that can be accessed in a browser. Or run almost anywhere. So you can run it locally on a Windows machine, on a Mac OS machine, on a Linux machine, or somewhere in the cloud, which is basically what we're doing here. There you go. So at the very basis of all of that is containers. So the software containers, that means lots of software packages are basically packaged in like a super mining reduced virtual machine. But that has all these dependencies that the software needs, including the GLIP C and other tools that it needs to do all its operations, right? So at the core, we have these Neuro containers, and there's lots of them. These containers have like stuff Studio, GLab, field troops, and so on and so forth. For free surfer, there's a few accessibility layers underneath it. But in a way, that accessibility layer is a little bit arbitrary. And it's not the sort of core. If you have the container, and for example, when I've been talking about HPC systems, you will use different accessibility layers. So you have different accessibility layers depending on your system. But they all arrive using the same containers, and that's how they become all comparable in the results and the output that they achieve, right? So it's a bit of an abstract concept one sort of needs to grasp. Containers are nothing terribly, so the Neuro containers are basically the core of the Neurodesk project. People can contribute containers, so everybody can contribute a container for a software that they think they would want to use. Containers are not necessarily terribly new. Um, I think what I like a lot in what we're using is actually the accessibility layers underneath it, because they kind of make it especially elegant. And you're gonna like including the service, the workstation, the server that you have access to online. You have access to the workstation already. Is anybody here? Okay, okay, wow. Who has access to the Neurodesk the virtual cloud server already? Do you see it on your screen? You need to type vss.neurodesk.org in your screen, and then you'll notice if it works or not.
Yeah, it's just if you can go to the web page. If you go to vss.neurodesk.org and it loads, then you've got access. Yeah.
I'm on their website.
You're on a website, yes, and it should look something like no, that's not going to work. That's also now Zoom is in my way. Of course, it is on. You can't see anything anyway. Let me just log in there, and then I can share a different. So it looks something should look something like this. Stop share, and I'll share a different screen. And I share that one. All right. Oh yes, but it's not showing it on that screen now. I'm sharing it on Zoom, but not with you guys because PowerPoint is in my way. Okay. All right. It should look something like that. And all the sort of cluster that you see around is basically why I'm struggling to control my computer. Zoom kind of like, no, doesn't like me. So it looks something like that. Turn up the volume. No, just don't. Here we go. So this is kind of starting. Almost there. So who has seen this screen? All right, couple of you. So this is the virtual cloud computing environment that we basically have prepared for all of you. Then you end up somewhere here. All right. Where you have this. All right. Yeah.
Neurodesk does sorry, VSS does Neurodesk.
Yes.
Go created Neurodesk does work.
Yes. That'll be a website.
And is there a way to again access the internet workforce through Neurodesk instead of VSS?
No, I don't think so. No, it's something very different. One is a website, and the other one is a Jupyter Hub. So it's just the address is very similar, and they're but it's something very different.
This is different.
Come again? The file list is different, yes. Because I'm in the shared folder and you're probably in your home folder, but don't worry too much about that quite yet. All right, so let me just continue with my presentation and get my Zoom out of the way, which is just, I know Zoom, do Zoom people see it? No, they don't. Oh, Jesus Christ. Yeah, Zoom is a bit. Is it still sharing the screen? Stop share. Here we go. And now I share another screen. Here we go. Share that screen. All right, beautiful. And now I need to find a way to move that thing forward. Here we go. Yay. So you can also start a virtual desktop from that hub there, and we'll show you how in a moment. But basically, the clue is it provides you access to these containers. In containers, you can access either through this part here, but you can also access them through the command line by sort of typing ML, and that command line can either be the one in the Jupyter Hub or in the virtual desktop, and you'll figure out what that means in a moment. So if you type ML for module load AFNI, and it'll basically suggest to you.
Talking about get this.
That is in the virtual desktop, but you'll get there. Don't worry too much about it. There is another terminal in the Jupyter Hub. It'll basically it'll offer you which Acne. So it has several versions of Acne, and you can choose which version you basically start with. And that's sort of nice because you can start your project with one version of Acne, and then at some point you start a second project. There is a new version out, and you want to use a new version. You don't have to uninstall the old version and reinstall the new one. You can use, depending on which project you're working on, use different versions of Acne simultaneously, right? All right. Okay. Also, because that's the other thing, these containers, they're also accessible through you can install them on a HPC cluster. So I, for example, have that installed on a we have a cluster which is called NIASRA, stands for National Institute of Applied Statistics Research Australia, and it's a bunch of very big and powerful machines, we don't have a virtual desktop with the GUI and that sort of stuff on that server, but we can use modules, Neurodesk modules through a Neuro command, and I'll talk a little bit more how that works. Yes.
You mentioned containers, are these Docker containers similar
Yes.
to that?
Yes, they're singularity containers, right? They're singularity containers, not Docker containers. Yeah. So what we're using here is a Neurodesk in the cloud. So why would you want to run it in the cloud? Essentially, it has, once you kind of start doing that, you kind of find how addictive that is, because you can run a very lengthy analysis and check and see, continue how it works from home, from your laptop, from your phone, if you're that desperate. But the computation basically runs continuously, and you can close your laptop, power down your desktop if you like, go home, and you don't worry about it. And it basically just continues to do so. You can also share access to a virtual workstation. So several people can sort of work literally on the same workstation. We can actually do this here in this setting too. We can log into so everyone here has their own virtual workstation available, but we can actually log into them and look over your shoulder, kind of what you see, what you're doing, and potentially even sort of help you. You can also, depending on the flexibility, choose the RAM, CPU, or GPU that you need for a specific task. You can do something with a relatively small system. So what we have here right now, we have a large number of relatively small systems. I think it's 4 or 8 cores, 4 cores, and 60 gigabytes of RAM, I think. So which is pretty decent, the RAM. That's okay for a workshop, and it's sufficient. If you want to do really a high performance analysis, you probably want something a little bit more powerful, but you're not going to need 60, right? Yes. For example, yes, you can spawn 50 workstations. That's kind of what we anticipated as the worst case scenario that we will have to do. Apparently, we managed to spawn about like 60, and we're working on a few more. All right, I'm very confident that this will work. Stefan is actually quite amazing. Right. Yeah, so you can have your analysis running while you said that. Why am I saying it again? The other thing is that I personally appreciate a lot. It solves software problem for your lab. So I don't need to sort of like manage the software. Lab doesn't need to manage the software on like 5 locations. Lab basically just one. If a new student comes into the lab, give them access to a Neurodesk server, and the software problem is solved. Whether they come with a Mac that is 20 years old or with a brand new whatever, it doesn't matter. It's not my problem, right? Right. How's your access going? Any improvements here? Yes. On the virtual workstation that we have here. So we're planning to let it run for about 4 weeks, so you can continue working on your works, on the scripts, and the stuff that you're trying here. Unless I think we're probably going to scale a little bit depending on use. So if everybody of you uses it a lot, at some point, we start getting terrible bills from Amazon. And then we might have to end it further, but we're aiming for 4 weeks. Yeah. All right. Neurodesk is free, yes. A cloud workstation is not necessarily free because it has to run somewhere, and someone needs to manage that hardware. Yes. Yeah. And you can, if you don't have a cloud workstation, you can actually, there's also Neurodesk app that's very nice and very convenient. It kind of opens something very similar, but it's completely running local on your laptop. It uses a Docker container. It works on Macs, it works on Windows, all sorts of things. So when you kind of open your Neurodesk for the server, you'll be greeted with something that should look similar to that. And there's these kind of buttons there, and I kind of want to point you to the most important of these buttons. The one, what I circled in one here is basically, if you click that, you will open a Jupyter book. We'll be working a little bit with Jupyter books here today. The button at the bottom opens a terminal. A very convenient terminal. This is kind of like my most favorite terminal of the entire system, but there's other terminals out there. The one in the virtual desktop. The other thing is this button here, number 3, that opens a virtual desktop. And in that virtual desktop, you can basically look at MRI imaging data and visualize them, which is slightly harder. It's definitely not possible in terminal. It's slightly harder on the Python Jupyter book, but it's not impossible, and that actually can also be quite nice. And you can open a shell in that virtual desktop too, but that is a little inconvenient, I think. But that's just my personal thing. And then probably part number 4, on the side here, you have like a file manager where you have access to the files that you need. And it's these files that you have here, they are basically shared through every sort of like incarnation or every aspect of that server, right? So you can access the same files from your Python, for your Jupyter books, from your terminal, and from the virtual machine. It's the same files. Okay, so it's just one also, what you probably for this workshop here at the moment, these files are yours, so they're like separate. Everybody has their own things here, except there is this folder which is called shared. If you go in that folder, that is shared for the entire server. Okay, so everybody has everything that you kind of put in here in your home directory. That includes things on your desktop in the virtual server. Is your own, and this is like your own personal space where you can go wild and don't annoy anybody. But we also have this for the setup space, whatever is there, and that's mostly the virtual material that is basically accessible by everyone. All right. Why is that coming again? Right. So in a way, I'm kind of doing this on a sort of familiar level. The server that what we're kind of using here is very good. If you try to do impossible tasks, that is, for example, teaching undergraduate students neuroimaging analysis and programming. Yes. All right. So I have done that. So you may consider me crazy. But actually it was a pleasant experience. So I have run last year in spring, Australian spring, so that is September to December. An undergraduate subject, 3rd-year undergraduate subject called Systems, Neuroscience, and Imaging. And that's kind of like a screenshot from the middle side. Kind of these boxes that you see all here, like week 2, week 5, week 7, week 10, week 12. Those are basically tutorial classes that I run, and these tutorial classes, I basically had a Neurodesk server very much alike to the one that we're using today, and it worked. So I'm actually confident we're going to get this working here too. Why I'm telling you that is, I Some of you might be at some point, know someone who and looking. This solves a lot of problems. This solves a lot of problems. The way I organize these, people have five labs, classes, each hours, so there's few labs, but they're very long, kind. To do that, it's a very normal tutorial that I'm basically about 1.5 hours, and we have 10 of them. I basically designed that in five classes of 3 hours. And that worked very well. So, any similar environment, I can strongly recommend that. And the topics that I've been using there is in platform 1. I did like a basic introduction to the platform, a command shell, a GitHub, basic Python, and I also introduced students to Linky integrated model. And actually I have a nice tutorial or like nice Jupyter book where you can actually play with a very simple, very basic Linky integrated fire sort of thing. And I like it a lot because I stole it, but so I didn't write it myself. I couldn't have written any better. But it's very nice introducing these kind of principles of sort of what neuroscience there. So that was 3 hours, and then there's another 3 hours where I basically did basic introduction to ITK Snap and Libabo, which is basically kind of ways to look at files. One Libabo from a Jupyter Hub interface or Python interface, ITK Snap, and the desktop. The third class was running on FreeSurfer. The fourth class was running on the Amatrix Batman tutorial for DWI imaging. And the last class, that's where I learned a valuable lesson of things that I didn't understand, where I tried to actually do one of the things that Noah will be doing today, except I didn't have Noah that handy at that moment. We had it running, it was all working, and then it broke. So much about reproducible science that doesn't ever break. But what we hadn't, or what I hadn't realized, is that what Neurodesk does, it freezes the modules of something like FreeSurfer. So everything that is in a singularity container, stuff that you access through the command line. The Jupyter Hub interface that we're basically using today, it's actually a floating one. So it's basically constantly updated. And it's also not necessarily a system. So you can install some modules in that sort of interface. Then you close your app and you reboot it, and it's gone. But what caused that problem? So we thought that's not too bad. We just install all the modules that we need. But some packages, like a widget that displays nice quality surfaces, was updated and then refused to work with the code. And we had no clue what happened, because in our eyes, nothing had changed except like from one day to the other, it didn't work anymore. And that's sort of kind of like where I understand the concept of Condor environments. So Condor environments are actually something that can freeze that. So this is the way how you can make a sort of Python environment with all these little packages that are part and components of Python, so you can freeze it sort of in time, and it's not going to change anymore, right? So if we had known that, we would have been able to run that. All right. Who here has basic understanding of Python? Oh, that's beautiful. So, part of the classes was like a very basic introduction to Python, kind of how does Python work, how does the most fundamental things work. Yes.
Teaching maybe for teaching purposes, they still have to also work if each student wants to work on their all day.
Probably, yes.
Okay.
Yes, I think so. So there is a couple of when I wasn't so sure, and I'm still not 100% sure that I'll be able to afford and actually spawn another of these on cloud services for a class of 60, 70 students. My fallback plan is that you use the app. Yes, but it's nice, it's good. It has many advantages, like, independent from the web, which is neat. But it also has a couple of disadvantages, and it also makes it harder for me to look over students' shoulder, for example, right? So if students look completely stuck, I can't dial into their server and can look what they're actually doing and find out that they're basically just playing spelling capital or whatever, ever else they're kind of doing wrong, or they just deleted some module and I need to kind of reinstall it and all this sort of stuff. Yeah. All right, so I'm not going to go into detail here then. Yes, leaky integrated fire. So this is kind of one of the things that I kind of want to show and tell. So as I pointed out, I stole it from Dan Goodman, so I didn't actually, I manipulated it entirely a little bit. But basically it's a very simple Jupyter Lab script that has probably about 20 lines at most. Maybe it's 25, and these lines include a plot, and they also include these little sliders, which is where you basically can control different sort of parameters of a sort of very basic leaky integrated fire model, or where you basically got these kind of neural impulses sort of coming in. And when you get over a threshold, the cell fires next potential, and then basically gets reset to the baseline. And you also have this decay function in there that after every action potential, the potential kind of decays back towards the baseline. And if the second action potential comes in before it is decayed, they basically start to add up. Right? So kind of demonstrating these very basic principles of neural sort of integration. And I have actually that, so that is one of the worksheets that I have sort of in the material. So if you go into the shared folder, and then we have lecture 01, lecture 02, lecture 03, which basically indicates the stuff from myself in lecture 01, from Noah in lecture 02, and from Fernanda in lecture 03. So that's basically what we have hidden the material for everyone to access. So in lecture 01, long sentence to finally come back to where I wanted to go. I have this Jupyter notebook there for the nuclear fire, and you can run it and play it, and I hope you like it. All right. So final thoughts from my teaching experience. It actually worked pretty well. Especially even though my students had a very basic level of computer experience, probably using smartphones a lot. Tips from my side, Amatrix Batman tutorial was probably a little bit too much for them. But yeah, I need to probably trimming it a little bit, get more the interesting bits and delete a couple of the not so fascinating stuff. As I said, pointed out, one pitfall near desktop Python does automatic updating, so kind of keep it simple if you don't require too many complicated sort of packages to install that will run less risk that something does change anyway. I think it was a pretty unique situation that it failed. I think we're using a couple of very extravagant sort of packages for our demo there. Yes, but solution there is Python Conda environment. So I'm actually quite confident I can make this work this year. Right. Another thing is obviously you need a certain Zen mentality in classes. More Zen mentality that I'm displaying here right at this very moment. That is because I'm running on a relatively tight schedule today. But these classes, they were 3 hours long, and I just wasn't on a tight schedule like that. So that's important. Right. I guess I could have learned that for today. I also kind of want to use this opportunity to kind of say, if anybody of you have any sort of fun Python-based tutorials or any type of stuff, like a leaky integrated fire neuron or something else, please tell me so. I'm looking for those. If someone needs stuff like that, talk to me. I can probably share a bit of information on that. So I'm sort of like on a bit of a quest to create a bit of like an interest group of people who like to share these sorts of things, right? So get in touch with me, make some suggestions, and maybe we can help each other. I would basically suggest right now here, what's the time? 10:02, I've got 10 minutes. Probably we don't have time to play hard. So so the last thing that I wanted to comment on is NeuroCommand. NeuroCommand is the interface to run these containers on an high performance cluster. So it's command line based only. As I said, so this is kind of what you see on a high performance cluster to which we have access to in SSH essentially. So we kind of like, dial in there, password in. Then the next thing that you need to do is run conda activate neuron. Once you basically type that sort of command, you command line activate a conda environment that allows you to load neural containers. So then you can type this line module load, for example, 3, and then you press tab. Basically says, okay, well, we have so these are our options. Matrix 3, and we have matrix 3 tissue. If you want, there is a bunch of version of matrix there too. So yeah, come again. Is not, no, we're not, this is not a HPC system we have here. So conda activate neural command is only for HPC systems. Don't try that here now. Try that at home on your HPC cluster. Right, but I kind of like our cluster a lot because I have nice things available. For example, an NVIDIA A100 GPU card for some hardcore GPU in case I need it, and that's actually pretty fun. Right, a few practical tips about how to run a neural command should you be interested in doing that. So if you have access to a HPC cluster at some point in time, it's actually relatively basic. You start installing neural command as per instruction on the Neurodesk website, neurodesk.org, without the DSS in front. This is the website that gives you lots of instructions, lots of background material. The instructions are relatively straightforward and work. Little tip, it'll ask you then whether you want to install if you want to download all the containers locally, or whether you want to use the CERN virtual file system. I probably would suggest you actually download these containers locally on your HPC system. They don't take that much space. The drawback of that is when there is new containers, you don't get them automatically. You basically have to update them manually. But it's good on HPC systems that can have that. So once it is, you need to run under conda activate neural commands. This is kind of what and then it's basically armed and ready. And then you can use model load your container, and then you can use that container. I also recommend that you use tmux. So basically the problem is when you dialing into a HPC system using an SSH connection, they sometimes get interrupted. And if you basically want to do something for like a week or so, there's actually no chance your your SSH shell will survive for a week. Now you can run your commands using no hub. That's not a big problem. Like so don't connect the shell rental. That doesn't work. That doesn't work with because it'll kill the conda environment anyway. So your script may survive, but the conda environment dies, and then your script dies. But if you use tmux, you can basically create a virtual shell that does not close when your SSH connection closes. Right. So that's basically what you need to do. This is just some basic tmux commands in case anybody wants them. Tmux is a virtual shell. So you basically create a background shell and that doesn't close when your SSH shell closes. So if your SSH shell closes, you can dial back in again and it works again. All right, so what can you do with that? You can do stuff like that. This is from our Human Brain Atlas project, where we basically acquire super high resolution quality T1, T2, and DWI data. And we end up, we basically average many low quality images that are slightly moved relative to each other, and then we construct a high quality image from that. That way we can acquire MRI images at qualities that scanner can't normally. So we can pass the resolution barriers that scanner has, that allowed us to get like a quarter millimeter resolution to T1, T, sorry, or T2. And it basically works for averaging super resolution scans. And yeah, that's basically what it is. I like to kind of demonstrate here, in particular for our DWI data. We acquired our DWI data. There's not many people who have higher resolution in DWI, but it's not that great, 1.25 millimeters, right? But we basically have, if you get a lot of DWI data and the same protocol over and over again, the subject will have moved in between. And you can actually use these images to average them. And this is the outcome resolution that we basically achieved. And I kind of like to point here at dentate nucleus here in the cerebellum. We can actually see in our DWI data, which is pretty easy. And if you're sort of a demonstration that that process does cover a dramatic amount of resolution. And I think I'm sort of run out of time. If I'm continue talking, Noah will get angry with me, and I don't want that.
Thank you, Mark. So by the way, we think we have a solution to the Neurodesk instance. Everyone who hasn't been able to log in, go ahead and go to ess.neurodesk.org and attempt to log in with your GitHub username. It should work now, even if you haven't received an invite. And that will last until the end of this workshop. After that, you'll have to wait till tomorrow so we can invite you again. But right now, it's just open to anyone on GitHub. So.
Actually, that was shut off. But you can.
Oh, sorry. Yeah.
You can email me your GitHub username.
So
I can add you.
So Fernanda's email address is one of the other ones that the email I sent you earlier. It should be on that. Sorry, the email I sent you earlier today. Fernanda is also CC'd on that email. Please send Fernanda an email with your GitHub username as the subject of the email. That would probably be easiest. And then she will add you, and then you'll be able to go ahead and join the instance. And that's good because I'm about to start talking about basically we're going to build a reproducible pipeline for analyzing fMRI data together in just a minute here when I get started.
Right, I'll go. I stop sharing.